All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is graphing lines. We were focusing on sketching some slope before this. This is part of a series on Algebra 1 Kuta worksheets, and this is the next one in that list, which is having to do with sketching the graph of each line. Let's jump into number 1. I'm going to just show you what the answer is for number 1, and then we'll talk about why I did what I did in a second. So I'm going to put a dot right here, and then 1, 2, 3, 4, 5, 6, 7, 1, 2, right there. And not a perfect line, but it's all good. Okay, so something like that. And that's what we're told to do. We're told to sketch the graph of each line. So why did I do that? Okay, well, here's what you need to know. When the graph is like this, it's in a certain form where you have the y, then the equals, then an x, and then a number that's like by itself, right? And there's also a number over here usually. Okay. If you don't see a number in front of x, there's actually a 1 there. Okay, so be really careful with that. I see that mistake a lot. But here's the thing. They call this m for slope. No idea why. I tried to look it up once, and there's no good answer because m doesn't sound anything like slope. Slope doesn't even have an m in it. Who knows? But it's m because somebody decided. So that's the slope. And then they call this other number b for y-intercept. Again, there's no b in y-intercept. I just double checked. There's no b in y-intercept. I don't know why where they're coming up with these letters, but they did, and now we're here. So now we have to deal with it, I guess. M is the slope, b is the y-intercept. Slope, it tells us where to go, not where to start. You cannot graph the slope. It would be like if I told you, like, hey, I'm cruising at 70 miles an hour, and you're like, oh, I know where you are. I'd be like, no, you don't. If I told you I was cruising at 70 miles an hour, the only thing you could maybe say is like, oh, he's probably on the interstate, unless I'm like going maybe a little bit too fast on some other road. But if I'm on the interstate, okay, you still don't know where on the interstate. If I tell you I'm going 70 miles an hour, that doesn't tell you where I am. If I tell you where I am, hey, I'm at the intersection of Fowler Avenue and I-75. Okay, now you know where I am, but do you know where I'm going? Well, if I'm not moving, then I'm, right there. But if I'm going somewhere, where am I going? Right? So you need both. If you're going to graph a line, you need to know where the line starts, so to speak, and where it's going in that order. In that order. So that's why when we're doing this stuff, we have to know where to start, which is B, right? This is the start. And this is where we're going. This tells us where we're going. All right, let's go ahead and go on to number 2. Number 2, 3. 1, 2, 3. Negative 6. 1, 2, 3, 4, 5, 6. Right there. Boom. All right, there's the answer. So notice that for both number 1 and number 2, this number is the y-intercept, which means it's where it intersects the y-axis. Do not go left or right. There is also a 3 on the x-axis, but it's not going to intersect the 3 necessarily. I mean, it could. It's like possible, but it didn't in this case intersect the 3. It does intersect the 3 on the y-intercept, so go up or down to get to the point where we start at. All right, so the y-intercept, somewhere on the y-intercept is where we're going to start. Right, so you start on the y-intercept. Right, somewhere on the y-intercept, meaning the y-axis, right? The y-axis, the thing that goes up and down. And then for the other one, so I went down 6 spaces from 3, went down 6 spaces, and I went to the right by 1. So you might be like, well, how did you know to go to the right exactly 1 space? Well, because when you have slope, you want to write slope as a fraction, because the top, right, m equals rise over run. And what's the opposite of rise? Well, fall. The opposite of rise is fall, right? Or something like it, maybe. So if it's -6, if I'm rising -6, that means I'm actually going down. I'm falling 6. And then I'm running 1. And I knew the denominator was 1 because if you divide any number by 1, it doesn't change the number. So I can write any number as a fraction if I divide it by 1. All right, number 3. Number 3 is going to kind of put a little bit of a kink in our method here, but not by a whole lot. If it's not already in what's called slope-intercept form, what we saw earlier, you can sometimes just put it in slope-intercept form. Like, I don't know if this is helpful, maybe 0x minus 5. I can write 0x there because there's no x. 0 times whatever x is going to be 0, right? 0 times x minus 5. No matter what x is, y will be -5. So for instance, well, actually, let's go ahead and graph this. So I would start by going down 5. And then let's write this as a fraction, 0 over 1, right? You can write any number over 1, even 0. 0 over 1, so I rise 0. I don't go up or down at all, but I run 1. Here's your line. Okay, now I wouldn't recommend doing it like this every time, right? I wouldn't do it like that all the time because it's just, a lot of work to, do extra stuff before you graph it. Here's the deal. When it says y equals -5, the reason why that's a horizontal line, like the x-axis, is because y is stuck. You don't see x, right? X is nowhere to be found. X is free. You don't see an x in the equation. X is free to do whatever it pleases. Y is not. Y is stuck. Y is in jail at -5. It's the -5 jail, and it's stuck there, and it can't get out. Solitary confinement. X is a free man. He can go and come at any point, anytime, anywhere. X can be any number. Y is stuck at -5. That's why it ends up being a horizontal line, and that's why later on we'll probably see, like for number 6, an x equals a number, and it does the opposite. But let's go ahead and move on to number 4. Okay, so 1, move up 1. Okay, that's the start. And then I rise 6 and run 5. 1, 2, 3, 4, 5. I kind of ran out of space here, but I can just kind of make an extra bar, right? You can draw outside the lines a little bit here. That's okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. All right, if they don't give you enough space, make enough space. Okay? You're the one making the rules here. Boom, boom. There's our graph. Go up 6 over 5. It's positive slope. Okay? One way to make sure you have the right slope, positive or negative, is to imagine a person going from left to right on the line. Right? If he's going this way, is he going to have to climb or go down? He's going to have to climb, right? So in the same way over here, it was -6. If my person is going down, first of all, this is going to be a fun roller coaster ride, because that's quite the slope. He's going down that thing. If he's going from left to right, he's sliding down. Okay, so maybe that's helpful, maybe not. But that's how you can check to make sure your slope is positive or negative like it should be when you graph it. All right, let's move on. Go to green now. We're going to go up 2. That's where we start. And then we go up 1 over 4. 2, 3, 4. Just like that. And notice I don't graph any more than 2 points. You can graph more than 2 points if you want, but that's just extra work. You can totally do that. You can totally graph. I mean, over here, if I go down and over, there's another one right there. But that's more work, right? So it's up to you whether you want to do that or not. But when you do more work, just remember that you run the risk of doing it wrong. If you do more work than you have to do and you do it wrong, then you might get the problem wrong even when you got the first part right. You did what you had to do to get the right answer, but then you kept going and did something else wrong after you got the necessary things to get the right answer. You see what I'm saying? So when you do more work, it's not like you're more noble or you're better. You're just running the risk of making a mistake. So you only need 2 points. If you're going to graph a line, you only need 2 points. Okay, so I would recommend only graphing 2 points and then just calling it a day. All right, now number 6. Number 6 is definitely not in slope-intercept form. But, like I was saying earlier, the whole principle behind number 3 is when y is equal to -5, y is stuck at the y value of -5. So in like manner, x is stuck now. X is now stuck at 5. Here's 5. Okay, but specifically this point is 5, 0. Y can be anything. Y could be 1. X would have to be 5. That would give me the point 5, 1. So it makes a vertical line. Okay, and if you're wondering, like, wait, but the y-axis, how is it that x equals 5 is vertical just like the y-axis? Wouldn't the y-axis be like y equals? Well, actually, no. The y-axis, the equation of the y-axis, is actually x equals 0. It's when x is 0. That's the equation of the y-axis. Because y-axis represents y points. Y points are free. And it's when x is 0. It's when x is right at the very center. So in the same way, the x-axis is y equals 0. Right? Let that blow your mind, potentially. All right, let's move down to number 7. This time we don't see a number. We don't see a number. So just like before, we didn't see an x, and we kind of just created one. Right, back on number 3 here, we just kind of created a 0x. Well, we can do the same thing here. If I add 0 to 5 over 3x, does that change anything? No, right? If I add nothing to something, I get the same something. So I can add 0, and that's fine. And then that's useful because now I see that the y-intercept is actually 0. It's right here. So we start at the origin, actually. And then I use the slope to get the next place. 1, 2, 3, 4, 5. 1, 2, 3. Right? And like that. X equals 0. Okay. Well, x equals 0 is going to be a vertical line. And it's actually the y-axis. I think we just talked about this, actually. It's right here. The y-axis. The y-axis is x equals 0. And the x-axis is when y is equal to 0. All right, number 9. We're going to go up 3. And then we're going to go down 1. So I like to always have the negative go to the top number. It doesn't have to. You can make the negative go to the bottom number, but you cannot make the negative go to both numbers. Negative 1 over negative 3 is equal to 1/3. Negative 1 over negative 3 is not equal to negative 1/3. Okay, so don't get those confused. If you have a negative over a negative, it makes a positive. That negative is right in the middle, meaning it can dip one way or the other. Like if you have like a ball and you're at the top of a hill, like you have a mound of dirt or something, and you put a ball right at the top of the hill, that ball might start rolling. It might start rolling a little bit to the left or to the right or, back or forwards. If you put it right at the very top, it could tilt either way. And that's the same thing as this negative. It's right in the middle. You could tilt it either way. You could tilt it towards the 1, or you can tilt it towards the 3, but you cannot put it on both. It's one negative. That is one negative sign. It belongs on one number only. Okay, hopefully that's helpful. I see that mistake a lot. So this negative, I like to put the negative on the top number. That's just my preference. I would go down 1 and then write 3. 1, 2, 3. And there we go. Minus 4. Go up 1 over 5. 2, 3, 4, 5. And there we go. All right, moving on. We're actually almost done with this thing. Can you believe it? Because look at this. Here's the answers. We're on the last 2 already. Woo, quick worksheet. Negative 2, up 1 over 2. There it is. And then right here, up 5. This is 2, which is 2 over 1. So I go up 2 over 1. And there we go. We're done, actually. That's it. Now, the only thing they didn't do that I'd like to show you real quick, that you will run into at some point probably, kind of surprised they didn't have an example like this, is what if I said y equals x plus 1? Right? How would you graph that? Well, we would start at 1, right? But then what? What's the slope? Is it 0? There's no number in front of x. Does that mean it's 0? No. If there's no number in front of x, it couldn't be 0 because 0 times anything is 0. There wouldn't be an x at all. Like we showed on, I believe it was number 5 or 3. No, if there's no number in front of x, it's 1. Like if I say I have a pencil, right? I have a stylus, right? That means I have 1 stylus. I didn't just tell you that I had 1. I said I have a stylus, right? But that means I have 1. I have 1 stylus. Well, I mean, I have more than 1 stylus, but this one right here is 1 stylus. So then I have 1, and then any number divided by 1 is still that number. So the slope then is 1 over 1. It's rise 1, run 1. So it'd be like that. Okay. So if you run into that, be careful. It's not 0, because 0 times anything is 0. If it was 0x, you wouldn't have an x. It's not 0, it's 1. Right? So remember that, and you'll be good to go. That's the only one that I didn't see on this worksheet that you'll need to know, because that's a tricky one, and I see people make a mistake on that a lot. So I hope this was really helpful for you. I have another really helpful thing for you. It's called the 5 math mistakes everyone makes and how to avoid them. It is for free on my website, myersmathematics.com. You can go there in the description below and go check that out. It's just a little PDF guide to help you to look at what are the common ways that people make math mistakes. I'm sure you have committed at least 2 or 3 of them. And you can figure out then what the solution is. I have a solution to each one, like what you can do about it and how you can start getting the right answers on your math questions. So if you're interested in getting the right answers on your math questions, go check out that guide. It's on my website, myersmathematics.com. Link in the description below. Here's the answers. And I hope you have a blessed day. I'll see you in the next